to simplify radical expressions. Radicals, also called roots, are the opposite of exponents. They even sound like opposites when we're talking about them out loud. We say, 6 squared, and, the square root of 6. And just like we can use larger and larger exponents like exponent of 3 and exponent of 4, we can also find smaller and smaller roots like cube root and fourth root. Simplifying radical expressions uses many of the same tricks you've learned in earlier math lessons for simplifying fractions or exponents. If you're new to the topic, start by learning how to simplify the square root of an integer. Simplifying the square root of an integer. Number 1. Factor the number under the square root.
Ignore the square root for now and just look at the number underneath it. Factor that number by writing it as the product of two smaller numbers. If the factors aren't obvious, just see if it divides evenly by 2. If not, try again with 3, then 4, and so on, until you find a factor that works. Example. Simplify the square root of 45. The first step is finding some factors of 45. You can't divide 45 by 2. So try dividing it by 9 instead, because 9 it's a perfect square. So the factor of 45, are 9 and 5, and then take the square root of 9 as 3, so 3 will be out. And the final answer is 3 and square root of 5. Take note. The perfect square are 4, 9, 16, 25, 36, 49, 64, 81 and etc.
2. Keep going until the number is factored completely. Remember, any number can be factored down into prime numbers, like 2, 3, 5, and 7. Keep breaking down the factors until there are no more factors to find. Now we have square root of 9 times 3, but we can factor 9 again, because it is a perfect square, to 3 times 3. Square root of 45 is equal to square root of 3 times 3 times 5. 3. Rewrite pairs of the same number as powers of 2. If the same factor shows up more than once, rewrite it as an exponent. Keep everything underneath the square root. In square root of 3 times 3 times 5, the number 3 shows up twice. Since 3 by 3 is equal to 3 squared, we can rewrite the whole expression as square root of 3 squared times 5. 4. Take any numbers raised to the power of 2 outside the square root. Roots and exponents are opposite, so they cancel each other out. If any factors are raised to the power of 2, move that factor in front of the square root, and get rid of the exponent. As long as everything underneath the root is one multiplication problem, you can always rewrite the expression like this, with a root over each product. Square root of 45 is equal to 3 square root 5. This is our final answer since there are no other exponents left under the square root. You're all done. Continuation of simplifying the square root of an integer. So we have number 5. Simplify the result so there is no multiplication left. In more difficult problems, you might end up with multiple numbers in front of the square root, or underneath it. Solve these multiplication problems to simplify the answer.
Example. Simplify the square root of 360. This takes a lot of factoring to break down. The prime factors of 360 is 5, 2, 2, 2, 3, 3. Rewrite pairs of numbers using exponents. It becomes the square root of 5, 2 squared, 2, 3 squared. Bring the 2 and 3 outside the square root. Simplify the numbers in front of the square root. So 2 times 3 is equal to 6 square root of 5 times 2. To get the final answer, simplify the numbers under the square root, so 5 times 2 becomes 10.
Another example of simplifying the square root of an integers. What is the square root of 18? First we need to factor. So the factor of 18 is 9 and 2. We can write this the square root of 9 and the square root of 2. Then take the square root of 9 as 3. And then rewrite the square root of 2. So therefore the square root of 18 is 3 square root of 2.
What is the square root of 75? First we need to factor. So 25 and 3 can be a factors of 75, and you can write this the square root of 25 and the square root of 3, so that we can take the square root of 25, which is 5, and then rewrite the square root of 3, so therefore the square root of 75 is 5 square root of 3.
What is the square root of 12? First we need to factor. So the factor of 12 is 4 and 3. We can write this the square root of 4 and the square root of 3. Then take the square root of 4, which is 2, and then rewrite the square root of 3. So therefore the square root of 12 is 2 square root of 3. What is the square root of 48? First we need to factor. So 16 and 3 can be a factors of 48. You can write square root of 16 in the square root of 3, so that we can take the square root of 16, which is 4, and then rewrite the square root of 3. So therefore the square root of 48 is 4 square root of 3.
Simplify. 4 square root of 98. We can rewrite this 4 square root of 49, and square root of 2. Because we can have 49 and 2 is a factor of 98. After finding the factors, you can write 4 square root of 49 and the square root of 2. So then take the square root of 49, which is 7, and then rewrite the square root of 2, and multiply 7 and 4. The answer is 28 square root of 2.
Simplifying cube roots and higher roots. 1. Find the prime factors of the number under the root. Just like square roots, the first step to simplifying a cube root, a fourth root, or any higher root is to factor the number under the root. Example. Simplify the cube root of 81. The prime factors of 81 are 3, 3, 3, 3. So we rewrite the cube root of 81 is equal to the cube root of 3 times 3 times 3 times 3. 2. Rewrite groups of the same factors in exponent form. If the same prime factor shows up more than once, rewrite them as an exponent. The cube root of 3 times 3 times 3 times 3 is equal to the cube root of 3 raised to the power of 4. 3. Simplify the root of exponents wherever possible. Just as a square root cancels out a square, higher roots cancel out matching exponents, for instance, cube root and raised to the power of 3. Check out this example to see how this works. The cube root of 3 raised to the power of 4 becomes the cube root of 3 raised to the power 3 times 3. Since the root and exponent match in 3, they cancel out, leaving only the base number 3. Plug that into the whole expression to get 3 cube root of 3. Since there are no more exponents left that can cancel out, this is simplify any multiplication and exponents. You'll often end up with exponents that don't cancel out, or with more than one number multiplied together. Solve for these so you end up with one number outside the radical, and one number inside it. Example. Simplify the fifth roots of 2 raised to power of 7, times 3 raised to the power of 5, times 7. This is already factored into prime numbers, so we can skip that step. Let's rewrite this as the fifth roots of 2 raised to power of 7, times the fifth roots of 3 raised to power of 5, times the fifth roots of 7. The fifth roots of 2 raised to the power of 7 becomes the fifth roots of 2 raised to the power of 5, times 2 raised to the power of 2, so that we can cancel the fifth power and put 2 outside of the radicals, and the 2 squared remain in the radical. Then the fifth roots of 3 raised to the power of 5 becomes 3, because we cancelled the fifth power. The fifth roots of 7 remain. Now we need to simplify, so the expression becomes 2 times 3 and copy the numbers inside the radical, so that we can have the fifth roots of 2 raised to the power of 2 times 7. So 2 times 3 becomes 6, and the fifth roots of 28, it is because we multiply 2 times 2 times 7. So the final answer is 6, and the fifth root of 28. Another example. Simplify the fifth roots of 7 raised to power of 6, times 7 raised to the power of 5, times 3. Let's rewrite this as the fifth roots of 7 raised to power of 6, times the fifth roots of 7 raised to power of 5, times the fifth roots of 3. By the rules of exponents, the root and exponent cancel out in the first term. The fifth roots of 7 raised to the power of 6 becomes the fifth roots of 7 raised to the power of 5 times 7, so that we can cancel the fifth power and put 7 outside of the radicals, and the 7 remain in the radical. Then the fifth roots of 7 raised to the power of 5 becomes the whole number 7, because we cancelled the fifth power. Then the fifth roots of 3 remain. Now we need to simplify. So the expression becomes 7 times 7 and copy the numbers inside the radical, so that we can have the fifth roots of 7 times 3. So 7 times 7 becomes 49, and the fifth roots of 21. It is because we multiply 7 times 3. So the final answer is 49, and the fifth root of 21. Simplifying fractions inside roots. 1. Simplify the fraction. What if a whole fraction is underneath a root? One way to solve problems like this is to ignore the radical expression at first. Simplify the fraction as much as you can, then see if the root lets you simplify further. Example. Simplify the square root of 100 over 4. Just ignore the radical and divide 104, and the answer is 25. Then take the square root of 25. So the final answer is 5. Another example. Simplify the square root of 36 over 4. Just ignore again the radical and divide the 36 and 4, and the answer is 9. Then take the square root of 9. So the final answer is 3. Simplify the square root of 81 over 9. Just ignore the radical and divide 81 and 9, and the answer is 9. Then take the square root of 9. So the final answer is 3. 2. Rewrite the fraction as two radical expressions instead. Some people prefer this other method of solving problems like this. Rewrite the fraction so there is one root in the numerator and another in the denominator. Simplify each root separately, then simplify the fraction. Example. Simplify the square root of 75 over 12. Since we can't divide easily, we will rewrite this as square root of 75 over the square root of 12. And simplify the numerator. The square root of 75 becomes square root of 25 times 3, and then take the square root of 25 is equal to 5. So that's why we have 5 square root of 3. Also simplify the denominator. The square root of 12 becomes square root of 4 times 3, and then take the square root of 4 is equal to 2. So that's why we have 2 square root of 3. Plug these back into the fraction. 5 square root of 3 over 2 square root of 3. Cancel out the square root of 3 to get 5 over 2. This is our final answer. Another example. Square root of 25 over 81. Just rewrite this as square root of 25 over square root of 81. And then take the square root of 25 and 81. So the answer is 5 over 9.
Adjust your answer so there are no roots in the denominator. Sometimes, the simplest form still has a radical expression. That's fine, but most math teachers want you to keep any radicals in the top of the fraction, not the denominator. Follow the rules for multiplying fractions to cancel out any roots on the bottom of your fraction. Examples. 4 over 9 square root of 5. We need to get rid of radicals in the denominator, so multiply square root of 5, so that we can cancel the square root of 5 in the denominator. 4 times the square root of 5 is equal to 4 square root of 5, and 9 times square root of 5 times square root of 5 is equal to 9 times 5. It is because square root of 5 times square root of 5 equals 5. So the final answer is 4 square root of 5 over 45. Next, 5 over 4 square root of 8. So multiply both numerator and denominator of square root of 8. 5 times square root of 8 is equal to 5 square root of 8. 4 square root of 8 times square root of 8 is equal to 4 times 8, because square root of 8 times square root of 8 is equal to 8. So simplify 5 times square root of 8 is equal to 5 square root of 8, and 4 times 8 is 32, so the answer is 5 square root of 8 over 32. 8 square root of 12 over 2 square root of 2. To get rid of this radical of our denominator, we need to multiply square root of 2. So 8 times square root of 12 times square root of 2 is equal to 8 square root of 24. Just multiply square root of 12 times square root of 2, becomes square root of 24. 2 times square root of 2 times square root of 2 is equal to 2 times 2, and then 2 times 2 is 4. Simplify. 8 square root of 24 divided by 4 is 2 square root of 24. Simplify again, the square root of 24 becomes square root of 4 times 6. And then, square root of 4 is 2. So just put 2 outside of the radicals, so the final answer is 4 square root of 6.
Combining roots of different kinds. 1. Convert roots to fractional exponents. You can rewrite any root as an exponent with a fractional value. The pattern is pretty straightforward once you're used to it. We have square root of x is equal to x, raised to the power of 1/2. Cube root of x is equal to x, raised to the power of 1/3. Fourth root of x is equal to x raised to the power of 1/4, and so on. 2. Combine the terms using exponent rules. Once you've converted your terms to exponent form, follow the rules of exponents to combine them into a single expression. Simplify. The square root of 3 and the fourth root of 3. So the square of 3 becomes 3 raised to the power of 1/2. And fourth root of 3 becomes 3 raised to power of 1/4. Since the exponent have the same base of 3, so we can add the power. 1/2 plus 1/4 is equal to 3/4. Once you have a single term with a fractional exponent, rewrite it as a radical expression. The denominator moves to the root, and the numerator stays as an exponent. If you have any multiplication or exponents left, calculate them so your final answer is in simplest form. The 3 raised to the power of 3 is equal to 27, so the final answer is the fourth root of 27. How to add and subtract square roots. 1. Simplify any terms inside the radicals when possible.
To simplify the terms inside of the radicals, try to factor them to find at least one term that is a perfect square, such as 25 5x5 or 9 3x3. Once you do that, then you can take the square root of the perfect square and write it outside the radical, leaving the remaining factor inside the radical. For this example, we are working with the problem 6 square root 50 minus 2 square root 8 plus 5 square root 12. The numbers outside the radical sign are the coefficients and the numbers inside it are the radicands. 2. Circle any terms with matching radicands. Once you simplified the radicands of the terms you were given, you were left with the following equation: 30 square root 2 minus 4 square root 2 plus 10 square root 3. Since you can only add or subtract like terms, you should circle the terms that have the same radical, which in this example are 30 square root 2 and 4 square root 2. You can think of this as being similar to adding or subtracting fractions, where you can only add or subtract the terms if the denominators are the same. 3. Add or subtract the coefficients of the terms with matching radicands. Now, all you have to do is to add or subtract the coefficients of the terms with the matching radicands and leave any additional terms as part of the equation. Do not combine the radicands. The idea is that you are saying how many of that type of radicand there are total. The non-matching terms can stay as they are. Here's what you do.
Here's how you simplify each of the terms. 6 square root of 50 minus 2 square root of 8 plus 5 square root of 12. You have to factor 50 into 25 times 2. So the 6 square root of 50 becomes 6 square root of 25 times 2. 2 square root of 8 becomes 2 square root of 4 times 2, because the factor of 8 is 4 times 2. 5 square root of 12 becomes 5 square root of 4 times 3. The square root of 25 is 5. So pulled out 25 on the radical, and put 5 outside of the radical and the number 2 remain. Square root of 4 is 2. So put 2 outside of the radical and the 2 is remain inside the radical. The same process, square root of 4, is 2. And put 2 outside of the radical and the number 3 remain because, is not the perfect square. 6 times 5, is 30, so the expression becomes, 30 square root of 2. The same process, 2 times 2, is 4. The expression becomes, 4 square root of 2. And 5 times 2 is equal to 10, so we have 10 square root of 3. You should circle the terms that have the same radical, which in this example are 30 square root 2 and 4 square root 2. Now, all you have to do is to subtract the coefficients since the operation is subtraction. The two coefficients of square of 2 are 30 and 4, so 30 minus 4 is 26. Then the expression becomes 26 square root of 2, and then bring down the 10 square root of 3. The final answer is 26 square root of 2, plus 10 square root of 3. Since they are not same radicals, we can't add or subtract the coefficient. Number 1. Simplify. Square root of 45 plus 4 square root of 5. Square root of 45 becomes square root of 9 times 5, because we need to factor 45 to 9 times 5, so that we can take the square root of 9. So the square root of 9 is 3, pulled out 3, inside the radical. So the expression becomes, 3 square root of 5, and then copy 4 square root of 5. Since they have the same radicals, we can add the coefficients, 3 plus 4 is equal to 7, and copy the square root of 5. The final answer of this example is, 7 square root of 5.
Number 2. Simplify. 6 square root of 40, minus 3 square root of 10, plus square root of 5. The factor of 40 is 4 times 10. The expression becomes 6 square root of 4 times 10, minus 3 square root of 10, plus square root of 5.
Since we can't factor 10 and 5 with has a perfect square. Then simplify. Square root of 4 is 2. So pulled out 2, inside the radical and the number 10 remain. Multiply 6 times 2, is equal to 12, so the expression becomes, 12 square root of 10, minus 3 square root of 10, plus square root of 5. Since 12 square root of 10 and 3 square root of 10, has the same radicals, we can subtract the coefficient 12 minus 3, is equal to 9, and then copy the square root of 10. So it becomes, 9 square root of 10 plus square root of 5. Then the final answer is, 9 square root of 10, plus square root of 5. Number 3. Simplify. 9 square root of 5, minus 2 square root of 3, minus 4 square root of 5. Since all radicands are prime numbers, you can look for the same radicands, 9 square root of 5, and 4 square root of 5, has the same radicands, so we can combine their coefficients, so 9 minus 4, is equal to 5, and then copy the radical. And the final answer is 5 square root of 5, minus 2 square root of 3. We can't combine the 5 square root of 5, minus 2 square root of 3, because they don't have the same radicals. Number 4. Square root of 9, plus square root of 4, minus 3 square root of 2. Just take the square root of 9, and square root of 4, because they are perfect square. So square root of 9, is 3. And square root of 4, is 2. Add the number 3 and 2. Then minus 3 square root of 2. And our final answer is 6, minus 3 square root of 2. Number 5. Simplify. Square root of 2 over 4, plus square root of 2 over 2. Just multiply 2 over 2 from square root of 2 over 2, so that we can have the same denominator, square root of 2, times 2, is equal to 2 square root of 2, and 2 times 2 is equal to 4. Then square root of 2 over 4, plus 2 square root of 2 over 4, is equal to 3 square root of 2, over 4. This is our final answer. How to multiply radicals. Multiply radicals without coefficients. 1. Make sure that the radicals have the same index. To multiply radicals using the basic method, they have to have the same index. The index is the very small number written just to the left of the uppermost line in the radical symbol. If there is no index number, the radical is understood to be a square root, index 2, and can be multiplied with other square roots. You can multiply radicals with different indexes, but that is a more advanced method and will be explained later. Here are two examples of multiplication using radicals with the same indexes. Square root of 18 and square root of 2. Square root of 10 and square root of 5. Cube root of 3 and cube root of 9. 2. Multiply the numbers under the radical signs. Next, simply multiply the numbers under the radical or square root signs and keep them there. Here's how you do it. Square root of 18 times square root of 18. Just multiply the two radicands. 18 times 2 is equal to 36 and copy the square root symbol. Square root of 10 times square root of 5. Just multiply 10 and 5, is equal to 50 and copy the square root symbol. Cube root of 3 times cube root of 9. Since they have the same index, we can multiply their radicands, so 3 times 9 is equal to 27 and copy the cube root symbol. 3. Simplify the radical expressions. If you've multiplied radicals, there's a good chance that they can be simplified to perfect squares or perfect cubes, or that they can be simplified by finding a perfect square as a factor of the final product. Here's how you do it.
36 is a perfect square because it is the product of 6x6. The square root of 36 is simply 6. Though 50 is not a perfect square, 25 is a factor of 50 because it divides evenly into the number and is a perfect square. You can break 25 down into its factors, 5x5, and move 1 5 out of the square root sign to simplify the expression. 27 is a perfect cube because it's the product of 3x3x3. The cube root of 27 is therefore 3.
Multiply radicals with coefficients. 1. Multiply the coefficients. The coefficients are the numbers outside of a radical. If there is no given coefficient, then the coefficient can be understood to be 1. Multiply the coefficients together. 2. Multiply the numbers inside the radicals. After you've multiplied the coefficients, you can multiply the numbers inside the radicals. 3. Simplify the product. Next, simplify the numbers under the radicals by looking for perfect squares or multiples of the numbers under the radicals that are perfect squares. Once you've simplified those terms, just multiply them by their corresponding coefficients. Example. Multiply the coefficients. Since the coefficient of square root of 10 is not visible, it is understood to 1. So 3 times 1 is equal to 3, and then multiply the numbers inside the radical. 2 times 10 is equal to 20, so the expression becomes 3 square root of 20. Simplify, you have to factor 20. So the factor of 20 is 4 times 5, and then take the square root of 4. The square root of 4 is 2, and then pulled out 2 inside the radical. So 3 times 2 is 6. So the answer is 6 square root of 5. Example. 4 square root of 3 times 3 square root of 6. Multiply the coefficients. Since the coefficient of square root of 3 is 4, and the square root of 6 is 3.
So 4 times 3 is equal to 12, and then multiply the numbers inside the radical. 3 times 6 is equal to 18, so the expression becomes 12 square root of 18. Simplify. We need to factor 18. So the factors of 18 is 9 times 2, so that we can take the square root of 9, and then take the square root of 9. The square root of 9 is 3, and then put number 3 outside the radical, so 12 times 3 is equal to 36, so the final answer is.
Multiply radicals with different indices. 1. Find the LCM or lowest common multiple of the indices. To find the LCM of the indexes, find the smallest number that is evenly divisible by both indices. Find the LCM of the indices for the following equation. 3 square root of 5 times 2 square root of 2.
The indices are 3 and 2. 6 is the LCM of these two numbers because it is the smallest number that is evenly divisible by both 3 and 2. 6/3 equals 2 and 6/2 equals 3. To multiply the radicals, both of the indices will have to be 6. 2. Write each expression with the new LCM as the index. Here's what the expressions would look like in the equation with their new indexes. 6th root of 5 times 6th root of 2. 3. Find the number that you would need to multiply each original index by to find the LCM. For the expression cube root of 5, you'd need to multiply the index of 3 by 2 to get 6. For the expression 2 square root of 2, you'd need to multiply the index of 2 by 3 to get 6.
4. Make this number the exponent of the number inside the radical. 5. Multiply the numbers inside the radicals by their exponents. 6. Place these numbers under one radical. 7. Multiply them. Example of multiply radicals with difference indices. Cube root of 5 times square root of 2. Find the LCM of indices. The equation becomes 6th root of 5 squared times 6th root of 2 squared. Simplify the radicands, so we have 6th root of 5 times 5 and 6th root of 2 times 2 times 2. Multiply the 25 times 8, and then the answer is 6th root of 200. How to divide square root. Dividing radicands. 1. Set up a fraction. If your expression is not already set up like a fraction, rewrite it this way. This makes it easier to follow all the necessary steps when dividing by a square root. Remember that a fraction bar is also a division bar. For example, if you were calculating square root of 144 divided by square root of 36, rewrite the problem like this: square root of 144 over square root of 36. 2. Use one radical sign. If your problem has a square root in the numerator and denominator, you can place both radicands under one radical sign. A radicand is a number under a radical, or square root, sign. This will simplify the simplifying process. For example, square root of 144 over square root of 36 can be rewritten as square root of 144 over 36. 3. Divide the radicands. Divide the numbers as you would any whole number. Make sure to place their quotient under a new radical sign. For example, 144 over 36 is equal to 4, so square root of 144 over 36 is equal to 4. 4. Simplify, if necessary. If the radicand is a perfect square, or if one of its factors is a perfect square, you need to simplify the expression. A perfect square is the product of a whole number multiplied by itself. For example, 25 is a perfect square, since 5 times 5 is equal to 25. For example, 4 is a perfect square, since 2 times 2 is equal to 4, thus, square root of 4 is equal to square root of 2 times 2 is equal to 2, so square root of 144 over square root of 36 is equal to square root of 4, then take the square root of 4 as 2. Factoring radicands. 1. Express the problem as a fraction. You will likely already see the expression written this way. If not, change it. Solving the problem as a fraction makes it easier to follow all the necessary steps, especially when factoring the square roots. Recall that a fraction bar is also a division bar. For example, if you were calculating the square root of 8 divided by the square root of 36, rewrite the problem like this: square root of 8 over square root of 26. 2. Factor each radicand. Factor the number as you would any whole number. Keep the factors under the radical signs. For example, square root of 8 over square root of 26 is equal to square root of 2 times 2 times 2 over square root of 6 times 6. 3. Simplify the numerator and denominator of the fraction. To simplify a square root, pull out any factors that make a perfect square. A perfect square is the result of a whole number multiplied by itself. The factor will now become a coefficient outside of the square root. For example, square root of 8 over square root of 36 is equal to square root of 2 times 2 times 2, over square root of 6 times 6. 4. Rationalize the denominator, if necessary. As a rule, an expression cannot have a square root in the denominator. If your fraction has a square root in the denominator, you need to rationalize it. This means to cancel out the square root in the denominator. To do this, multiply the numerator and denominator of the fraction by the square root you need to cancel. For example, if your expression is 6 square root of 2 over square root of 3, you need to multiply the numerator and denominator by square root of 3 to cancel the square root in the denominator. 5. Simplify further, if necessary. Sometimes you will be left with coefficients that can be simplified or reduced. Simplify the whole numbers in the numerator and denominator as you would simplify any fraction. For example, 2 over 6 reduces to 1 over 2, so 2 square root of 2 over 6 reduces to 1 square root of 2 over 3, or simply square root of 2 over 3.
Dividing square roots with coefficients. 1. Simplify the coefficients. These are the numbers outside of the radical sign. To simplify them, divide or reduce, ignoring the square roots for now. For example, if you are calculating 4 square root of 32 over 6 square root of 16, you would first simplify 4 over 6. The numerator and denominator can both be divided by a factor of 2. So, you can reduce 4 over 6 is equal to 2 over 3. 2. Simplify the square roots. If the numerator is evenly divisible by the denominator, simply divide the radicands. If not, simplify each square root as you would any square root. For example, since 32 is evenly divisible by 16, you can divide the square roots. Square root of 32 over 16 is equal to square root of 2. 3. Multiply the simplified coefficients by the simplified square root. Remember that you cannot have a square root in a denominator, so when multiplying a fraction by a square root, place the square root in the numerator. For example, 2 over 3 times square root of 2 is equal to 2 square root of 2 over 3. 4. Cancel the square root in the denominator, if necessary. This is called rationalizing the denominator. As a rule, an expression cannot have a square root in the denominator. To rationalize the denominator, multiply the numerator and denominator by the square root you need to cancel. For example, if your expression is 4 square root of 3 over 2 square root of 7, you need to multiply the numerator and denominator by square root of 7 to cancel the square root in the denominator. 4 square root of 3 over square root of 7 times square root of 7 is equal to 4 square root of 21 over square root of 49, and then simplify the square root of 49, so square root of 49 is 7. The final answer is 4 square root of 21 over 7.
Example of adding radicals. There are 2 keys to combining radicals by addition or subtraction. Look at the index, and look at the radicand. If these are the same, then addition and subtraction are possible. If not, then you cannot combine the 2 radicals. In example number 1, both radicals have the same root and index. The 2 radicals are the same. The square root of 11. This means you can combine them, as you would combine the terms 3x plus 7x. So now you can add the coefficients, 3 plus 7 is equal to 10, and then copy the square root of 11. Number 2 example. Since the 3 radicals has the same square root of 3, so you can add the coefficients, 5 plus 1 plus 2 is equal to 8, and copy the square root of 3. This next example number 3 contains more add-ins. Notice how you can combine like terms. Those are radicals that have the same root and index, but you cannot combine unlike terms. 5 square root of 2 plus square root of 3 plus 4 square root of 3 plus 2 square root of 2.
To add this, you need to combine like terms. 5 square root of 2 and 2 square root of 2 are like terms because they have the same radicals. Also the square root of 3 and 4 square root of 3 are the same radicals. 5 square root of 2 plus 2 square root of 2 is equal to 7 square root of 2, and square root of 3 plus 4 square root of 3 is equal to 5 square root of 3. Now we can't combine them because they don't have the same terms, so this is our final answer. Number 4. 3 square root of 5 plus 5 square root of 7 plus 8 square root of 5 plus square root of 7. Combine like terms. 3 square root of 5 and 8 square root of 5 are the same terms, so add the coefficients, which 3 and 8 is equal to 11 square root of 5 and 5 square root of 7 plus square root of 7. The coefficient of square root of 7 is 1, so we need to add 1 and 5 is equal to 6, and copy the square root of 7. This is our final answer because we can't combine unlike terms. Example number 5. Rearrange terms so that like radicals are next to each other. Then add 3 square root of x and the square root of x are the same radicals, so we can add their coefficients. 3 plus 1 is equal to 4, and copy the square of x, and then copy the second term, which is 12 cube root of xy, since they don't have the same radicals, so our final answer is 4 square root of x and 12 cube root of xy. Number 6 example. Simplify each radical by identifying perfect cubes. The factors of 40 is 8 and 5. The 2 cube root of 40 becomes 2 cube root of 8 by 5. The factors of 135 is 27 and 5. The cube root of 135 becomes the cube root of 27 times 5. 8 is equal to 2 raised to the power of 3, and 27 is equal to 3 raised to the power of 3. And then cube root of 2 raised to the power 3 is 2. That's why we need to pull out 2 from the radical sign, and then the number 5 remain inside the radical. Cube root of 3 raised to the power of 3 is 3. That's why we need also to pull out 3 from the radical sign, and then the number 5 remain inside the radical. Simplify again. 2 times 2 is equal to 4, and copy the cube root of 5. Now since they have the same radical, we can add the coefficients. 4 plus 3 is equal to 7, and just copy the cube root of 5. So the final answer is 7 cube root of 5. Number 7 example. Simplify each radical by identifying perfect square. The factors of 12 is 4 and 3, which has a perfect square of 4. And then rewrite 4 square root of 12 becomes 4 square root of 4 by 3. The factors of 27 is 9 and 3, which has a perfect square of 9. The 3 square root of 27 becomes the 3 square root of 9 by 3. 4 is equal to 2 raised to the power of 2, and 9 is equal to 3 raised to the power of 2. And then square root of 2 raised to the power 2 is 2. That's why we need to pull out 2 from the radical sign, and then the number 3 remain inside the radical. Square root of 3 raised to the power of 2 is 3. That's why we need also to pull out 3 from the radical sign, and then the number 3 remain inside the radical. Simplify again. 4 times 2 is equal to 8, and copy the square root of 3. Multiply 3 times 3 is equal to 9, and copy the square of 3. Now since they have already the same radical, we can add the coefficients. 8 plus 9 is equal to 17, and just copy the square root of 3. So the final answer is 17 square root of 3. Number 8 example is the same process of example number 7. Simplify each radical by identifying perfect square. The factors of 8 is 4 and 2, which has a perfect square of 4. And then rewrite 3 square root of 8 becomes 3 square root of 4 by 2. The factors of 18 is 9 and 2, which has a perfect square of 9. The 5 square root of 18 becomes 5 square root of 9 by 2. 4 is equal to 2 raised to the power of 2, and 9 is equal to 3 raised to the power of 2. And then square root of 2 raised to the power 2 is 2. That's why we need to pull out 2 from the radical sign, and then the number 2 remain inside the radical. Square root of 3 raised to the power of 2 is 3. That's why we need also to pull out 3 from the radical sign, and then the number 2 remain inside the radical. Simplify again. 3 times 2 is equal to 6, and copy the square root of 2. Multiply 5 times 3 is equal to 15, and copy the square of 2. Now since they have already the same radical, we can add the coefficients. 6 plus 15 is equal to 21, and just copy the square root of 2. So the final answer is 21 square root of 2.
Example of subtracting radicals. Subtraction of radicals follows the same set of rules and approaches as addition. The radicands and the indices must be the same for two radicals to be subtracted. Subtraction has been rewritten as addition of the opposite. In example number 1, we can subtract both coefficients, because they have the same radicals. So, 5 minus 3 is equal to 2, and just copy the square root of 13. So the final answer is 2 square root of 13. Number 2. The two terms has the same radicands and index. We can easily subtract both coefficients, which is 9 minus 5, is equal to 4, and then copy the square root of xy. So the final answer is 4 square root of xy. Number 3. Square root of x minus 4 square root of x. The two terms has the same radicand and index, and now we can subtract their coefficients, which is negative 1 minus 4, is equal to negative 3, and then copy the square root of x, so the final answer is negative 3 square root of x. Number 4. The two terms has the same radicand and index. We can easily subtract both coefficients, which is 8 minus 1, is equal to 7, and then copy the cube root of x squared, so the final answer is 7 cube root of x squared.
Example number 5. Since some of the terms are different, we can't easily subtract the coefficients. All we need to do is to rearrange the terms so that like radicals are next to each other. Then subtract. The new expressions is 4 cube root of 5a, minus 2 cube root of 5a, minus cube root of 3a. We need to simplify. 4 cube root of 5a minus 2 cube root of 5a. Have you noticed that they have the same radicals, so you can subtract both coefficients. 4 minus 2 is equal to 2, and copy the cube root of 5a. Take note, we can't combine 2 cube root of 5a and cube root of 3a. So that's why our final answer is this. Example number 6 has also different terms, so cannot easily simplify them. All you need to do is to simplify each radical by identifying perfect cubes.
Just factor the radicand, so the factor of 12 is 4 and 3, and the factor of 27 is 9 and 3, the factor of 48 is 16 and 3.
Simplify. Square root of 4 is 2, so pull out 2 inside the radical. Square root of 9 is 3, so pull out 3 inside the radical. Square root of 16 is 4, so pull out 4 inside the radical. And then multiply 9 times 2 is equal to 18. 3 times 3 is equal to 9. 2 times 4 is equal to 8. Have you noticed that they have already the same radicands and index? So now we can subtract the coefficients. 18 minus 9 minus 8 is equal to 1. So our final answer is square root of 3. Number 7. We have noticed that the terms has the same radicand and index. So just subtract. 5 minus 3 is equal to 2, and copy the square root of 8. We can simplify the radicand. The factor of 8 is 4 and 2. Then the square root of 4 is 2. So pull out 2 inside the radical. So simplify 2 times 2 is equal to 4, and copy the square root of 2. So the final answer is 4 square root of 2. Multiplying radical expressions. The product raised to a power rule is important because you can use it to multiply radical expressions. Note that the roots are the same. You can combine square roots with square roots, or cube roots with cube roots. But you can't multiply a square root and a cube root using this rule.
Example. Square root of 18 times square root of 16. Use the rule of multiplying radicals to multiply the radicands.
This means that we can multiply the radicands. 18 times 16 is equal to 288, and then look for perfect squares in the radicand, and rewrite the radicand as the product of two factors. Now we need to find the factors of 288 that has a perfect square. The factors that has perfect square is 144 and 2, and then rewrite as the product of two radicals. Simplify. Square root of 12 squared is 12, and copy the square root of 2, so the final answer is 12 square root of 2.
Another method of multiplying radicals in example number 1. First, look for perfect squares in each radicand and rewrite as the product of two factors. 9 and 2 are the factors of 18, and 4 times 4 are the factors of 16.
Now identify the perfect squares. Rewrite number 9 into 3 raised to the power of 2, because 9 is a perfect square, and also 4 times 4 into 4 raised to the power 2. Rewrite this as the product of radicals, and simplify. Square root of 3 raised to the power of 2 is equal to 3. And copy the square root of 2. Square root of 4 raised to the power of 2 is equal to 4. 3 times 4 is equal to 12, and copy the square root of 2. This is your final answer. In this example number 2, first, look for perfect squares in each radicand, and rewrite as the product of two factors.
9 and 3 are the factors of 27, and 16 times 3 are the factors of 16. Now identify the perfect squares. Rewrite number 9 into 3 raised to the power of 2, because 9 is a perfect square, and also rewrite number 16 to 4 raised to the power 2.
Rewrite this as the product of radicals, and simplify. Square root of 3 raised to the power of 2 is equal to 3, and copy the square root of 3. Square root of 4 raised to the power of 2 is equal to 4. Copy the square root of 3. 3 times 4 is equal to 12, and square root of 3 times square root of 3. So just multiply the radicands. 3 times 3 is equal to 9, and then take the square root of 9 is equal to 3. And 12 times 3 is equal to 36. So our final answer is 36.
Square root of 12x squared times square root of 3x. In order to solve this example, we need to use the rules to multiply radicands. We can rewrite this expression to square root of 12x squared times 3x, and then multiply them. 12 times 3 times x squared times x.
So 12 times 3 is equal to 36, and x squared times x is equal to x cubed. Just recall the rules of multiplying exponents. Now we are going to look for the perfect squares in the radicand. 36 is the perfect square, so rewrite this into 6 square so that we can easily take the square root, and x cubed can be rewritten as a product of x squared, and x then rewrite as the product of radicals. Now take the square root of 6 squared is equal to 6, and take the square root of x raised to the power 2 is equal to x, and the square root of x remain because x, it is not a perfect square. Simplify. 6 times x is equal to 6x, and copy the square root of x, so this our final answer.
Cube root of x raised to the power of 5y squared times 5 cube root of 8x squared, and y raised to the power of 4. Notice that both radicals are cube roots, so you can use the rule to multiply the radicands. 8 times x raised to the power of 5 times y squared times 5 cube root of 8x squared, and y raised to the power of 4. So the new expression is 5 cube root of 8 times x raised to the power of 7 times y raised to the power of 5. Look for perfect cubes in the radicand. 8 has to be rewritten as 2 cubed, Since x raised to the power of 7 is not a perfect cube, it has to be rewritten as x squared raised to the power of 3 times x. And y raised to the power of 7, it has to be rewritten as y squared raised to the power of 3.
Rewrite this as the product of radicals, and then take the cube root of 8 is equal to 2, and take the cube root of x squared raised to the power of 3 is equal to x squared. Cube root of y squared raised to the power of 3 is equal to y squared. And the cube root of x will remain, because x is not a perfect square. And then simplify, 5 times 2 is equal to 10 and copy the remaining expression, because we can't multiply them. So our final answer is 10, x squared, y squared and cube root of x. Dividing radical expressions. When you're multiplying radicals together, you can combine the two into one radical expression. There's a similar rule for dividing two radical expressions. If you have one square root divided by another square root, you can combine them together with division inside one square root. This property can be used to combine two radicals into one. It can also be used the other way around to split a radical into two if there's a fraction inside. Important note: notice that it says b cannot equal 0. This is because b is in the denominator and you can't divide by 0. An expression with 0 in the denominator is undefined. Think of the word no to help you remember. What about 0 in the numerator? It's okay to have a 0 in the top of a fraction. 0 divided by any non-negative number is just 0. Example number 1. In dividing radicals. Use the rule in dividing radicals to create two radicals, one in the numerator and one in the denominator. Simplify each radical. Look for perfect square factors in the radicand, and rewrite the radicand as a product of factors. Identify and pull out perfect squares. So the square root of 4 raised to the power of 2 is equal to 4, and the square root of 3 remain because it is not a perfect square. And then take the square root of 5 raised to the power of 2 is equal to 5, so our denominator is 5. So our final answer is 4 square root of 3 over 5. Simplify. Square of 18 divided by square root of 2. To divide two radicals, you can first rewrite the problem as one radical. The two numbers inside the square roots can be combined as a fraction inside just one square root. Once you do this, you can simplify the fraction inside and then take the square root. So 18 divided by 2 is equal to 9. And then take the square root of 9 is equal to 3. The final answer is 3. Number 3. Simplify. Square root of 160 divided by square root of 5. First, combine into one radical. Then simplify what's inside. 160 divided by 5 is equal to 32. Don't forget to look for factors that are perfect squares. So the factor of 32 that has a perfect square is 16 and 2. And then pull out factors that are perfect squares. Take the square root of 16 is equal to 4 and then copy the square root of 2. The final answer is 4 square root of 2. Number 4. Square root of 24x squared divided by the square root of 3x. First, combine into one radical. Then simplify the fraction on the inside. 24 divided by 3 is equal to 8 and x squared divided by x is equal to x. Make sure to continue simplifying until there aren't factors left that are perfect squares. So the factor of 8 is 4 times 2. And then take the square root of 4 as 2. Since 2 and x is not a perfect square, the final answer is 2 square root of 2x. Number 5. Simplify the cube root of 27x raised to the power of 9, divided by cube root of x raised to the power of 6. First, combine into one radical. 27x raised to the power of 9, divided by x raised to the power of 6, is equal to cube root of 27x cubed. Make sure to continue simplifying until there aren't factors left that are perfect squares. Since 27 is a perfect cube root, so just take the cube root of 27, is equal to 3, and cube root of x raised to the power of 3, is equal to x. The final answer is 3x.